Hi guys, Chris with Microsoft here with another exciting episode of What's New in Windows Server 2012. Tonight we're going to be talking about DHCP. There's a couple of pretty important changes that I need everybody to know about concerning this technology. We're also going to use this episode as another example of what you can do with Server Manager. So we've covered in my three-part series inside of episodes covering local server management, remote server management, and multi-server remote server management. We're going to be doing multi-server remote server management with one thing I did not cover in that episode, and I did that strictly so that I could show it off here. So what we're going to do is we're going to start off by installing a role here on DC1. And we're going to kick off the Add Roles and Features wizard by right-clicking that server and going straight to Add Roles and Features, picking role space to install. You're going to see it's already selected DC1 for me, so that's kind of a handy little shortcut. What I'm going to do is I'm going to go ahead and kick off the DHCP server role, and I'm also going to let it install the RSAT tools for that as well. And we'll go ahead and get that kicked off. I'm going to go ahead and kick this, even though it's not necessary. DHCP does not actually require a reboot, and we'll let that kick off. Whenever you have done remote installs in the past using Server Manager, if you've ever tried that, Server Manager has been tied in the past to the Windows servicing infrastructure, which it just isn't that way anymore. I could close this right now. My box is finished with what it needed to do. And, okay, so I had a previous role install that I had to kick off on this box previously, so I'm going to restart that server. I'm going to pause the video for just a second so you don't have to sit here watching me bouncing servers. Okay, so here we are again, back up to the same step where we were before. Actually, it's kind of good that I didn't let that finish, because what I really wanted to do also was show you how to export a configuration setting. So I've already made all these choices about what role I wanted to install. So I'm going to call this DHCP, just a little XML file. If we wanted to go look at what is actually in this, I'm going to open this with Notepad. So it's just got some settings based on what we chose in the wizard. This can be used again. So I click install. This thing kicks off, as I was starting to discuss before. This is not tied to the Windows servicing infrastructure. This is actually already kicked off on DC1, and my machine is no longer necessarily having to keep up with this. I can close this if I want, come back and look inside this red flag, and it's going to show me the feature install as it continues down here at the bottom. I'm going to go ahead and clear out some of these red failures so we can see this continuing on, and it's finished. And here in a moment, after it rescans that, it's going to come back and tell me that there's extra stuff we actually have to do. If you install DHCP, there's going to be post-configuration tasks that go along with that. Namely, we have to activate the DHCP server or authorize it. So refresh it, and it's going to say, hey, you're not done yet. Complete DHCP configuration. This will kick off a post-deployment wizard. So we're already able to do this. It's going to be, by default, doing this for me. Click that, and hey, we got ourselves a handy DHCP wizard. Alright, so that is ready to go. Let's do some PowerShell. I'm not much of a PowerShell person, but I'll show you a little trick here if you need to do this a bunch of times. I'm going to right-click that, run this as administrator. I'm going to actually switch over here. Let's go to users, and then Kyle, and then desktop, and make sure our make sure our file is actually out there. It's probably under the other Kyle. Yeah, Kyle. There we go. CD. Kyle. Desktop. There we go. Install dash Windows feature. Tab to complete. Now, what we're going to do here is actually dash, I believe it's configuration file path. There we go. Tab to complete. and then I can just tab again and find this little guy. DHCP.xml is what we picked a minute ago, and then computer name, MPUTER name, and we're going to do this for Contoso DC2. Kick that off, and we're going to see a PowerShell version of this. This is actually using the PowerShell modules for DISM. And so Contoso DC2 should now be getting the DHCP role installed. So nice handy little shortcut if you need to go to deploy any of your roles or features on another system. Certainly a lot of ways you could go about doing that. This just specifically is using the pre-configured XML file that you exported by using the GUI. That's handy for those of us who do not use PowerShell very frequently and need a little help. So what we want to do now is let's just pop back over here and do a quick little refresh. Then click our little red flag here, and we have another post-deployment configuration. We could probably do this in PowerShell. Honestly, I didn't look up and see how to do it. So now I've got 2 authorized DHCP servers. Alright, so now that they are DHCP servers, we can right-click them, and we should see that in the list of things we can do, DHCP Manager. Now, once again, we're on a Windows 8 machine, remotely managing these 2 servers. So I've got DC1 already in here because he's the one I right-clicked. I could add another server, go ahead and get this authorized DHCP server added into the console. And here we go. We're going to have 2 different DHCP servers loaded in to our view. And that's where I wanted to get to some of the new advanced features of what you can do with DHCP in Windows Server 2012. Alright. So I'm going to expand this out, and we've got server options, policies is new. We're going to be talking about policies, and we're going to be talking about some of the stuff we can do with that. But let's just create a new little scope just for testing purposes so that we can, we'll just call this test scope so we can do something interesting with it. And let's just say 10.1.2.5, and then we'll end that at 10.1.2.200, whatever. And I've got a 24-bit subnet and 8 down. Let's configure that later. All I need is a scope right now, just for illustration purposes. Alrighty. So you'll notice there's also policies here. So policies and high availability are actually the 2 things I want to talk about. The first of these subjects will be policies. You can create a server level policy or a scope level policy. We're going to create a scope level policy. Now, what a policy is, test policy, is the ability for me to do interesting things based off of the DHCP request. So when you request an address, an IP address from a DHCP server, you're going to obviously give it your MAC address. That's just kind of part of how networking works, but you're also going to give it things like the device ID and a few other things. So what you do is you say, well, okay, let's make some rules up. So we've got vendor class, we've got user class, MAC address, client ID, relay information. All this stuff gets handed off to the DHCP server as it is making this request. Probably one of the more common policies people will create would be a MAC address policy. Why would we do this? Well, let's say that I have a handful of devices that I want to group together and keep them grouped in DHCP here. Another reason I might do this is because I want to have different policies for different types of machines. Like if I want to take all of my print servers, all my print devices, so I go out there and get all my HP JetDirect, go grab the preamble for the MAC address for all JetDirect printers. Not hard to find. All vendors have to go and get a preamble for their MAC address, and so they're all going to be the same. Maybe I want to get all my IP phones and group them together. Maybe I want to take all my laptops in my organization and I want to give them a 1-day IP address lease, and then make sure that all of my desktops get an 8-day lease. And so there's a lot of stuff you can do with this, and you use your own imagination. But let's say 010101, and then we append a wildcard to this MAC address, and what I can say is that, or maybe another set of MAC addresses, or maybe a vendor class in this case. But we'll just stick for simplicity reasons 20202 append wildcard add. So now either that or this would work. We could also do AND statements. One way or the other, you're going to create this policy. Since we did this as a scope level policy, we can carve out a chunk of addresses inside of that. So we did 10.1.2.5 was the beginning of the policy. Maybe I just want to put these guys that match this policy into 10.1.2.150, and they'll be all grouped in that range. Right? I can give them different rules here. Like maybe I want to give certain devices a different gateway, or maybe I want them to have no gateway, or maybe I want to have a different set of DNS servers. A lot of different stuff you can do with this. Right? So here's my policy. Another thing that's important is processing order. So if I had a couple of different policies here, I could actually move these up and down. They're grayed out because I only have one, so that it'll process those policies in the order that I expect them to expect yeah. So they'll process them in the order that is expected from me. What I'm looking at for them to do. Okay, so the next thing is going to be a discussion about high availability. So what we're going to do here is actually create a highly available set of DHCP servers. And in the past, we had a couple of different options for this. So what you could do is, you could create a failover cluster and give it some shared storage and put a DHCP server into the failover cluster. And then you could turn around and make that highly available, and this was option A. Option B would be not really an official solution, just something we've kind of told people were in an option. You could create two DHCP servers, and you could do a split scope deployment. You might have 10.1. 0. whatever is your subnet, and you could give like maybe addresses 50 through 150 to the first DHCP server, and 151 to 250 on the other, and then whoever answers first would be the person who hands out the address. That gives you some high availability, but it's something that's going to be a little more difficult to manage, obviously, because you're going to have to go in. If you create a reservation, you're going to have to put it on both of them, so they both know what address to hand out of that range, and they're not actually communicating. That's what we've changed. We've given you the ability to create a high availability without the use of failover cluster, and more or less create a split scope deployment with some logic and some intelligence. This is all based off of the IETF task force's draft for how to create high availability servers. So we're using an open standard when we do this. So the way you set this up is to come in here, just right click on one of your servers, IPv4, and say configure failover. Right? And there are two modes that we can put this in. This is going to kick off a wizard, which is going to help us decide which way. So you can do this wizard in a way that would be good for branch office that just has one server, and we would use what we call a hot standby mode. Or if you have two servers that you can use in that branch, you can do a load sharing mode. Alright, so we have one scope that we can use. We're going to go ahead and just use that one. We're going to click next. We're going to go say, hey, I need a partner server. Now there's nothing on the drop down list because we haven't done one before, but it does know of authorized DHCP servers on the network, so we'll say, hey, this guy, Contoso DC2, is going to be my other server in this partner relationship. And so we'll click OK, and we will wait as my spinning blue circle spins so levelly around in circles there. We can give this a relationship name. Just use the default, it'll be fine. So there's some terminology we need to understand here, and so I'll cover all of this here for you. So the first piece up here is the maximum client lead time. So the maximum client lead time is mostly relevant to the primary server in the relationship. It's the length of time in which a lease can be renewed by either of a failover peer without contacting the other. When we talk about things like stale switchover interval, we'll talk more about that here in just a second because that's more relevant to hot standby. The 50-50 ratio is obviously just how much of the scope and the load balancing percentage either of these are going to have of the scope. Now, this is the local server, and this is the partner server. So if I wanted this server to carry a heftier weight of the the scope, then I just configure that right here. Enabling message authentication just means that when we set this up and as we communicate, we can create a password that these guys are going to use. Now, if I switch this over to hot standby, that's a little bit different. I make this the primary server, or I can make the partner server become the active. By default, we're going to have this guy be the primary, the one we're running the wizard from, and make the other one become the standby server. And then we see this address is reserved for standby server, and by default that's going to be 5%, which means 5% of the overall scope that the addresses in the scope will be held onto by this backup server. So we've got load balance mode, which means we're going to split the scope between two servers, very much like today when you're doing a split scope deployment. We've got two active DHCP servers. Either of them can respond. If we take one of them offline for maintenance during a reboot for the Windows updates on our monthly patching schedule, the other one's still up, he's still active, he's still doing his thing, and when the other guy comes back up, we're going to assume everything is okay, update the database, and they go on. The hot standby mode, on the other hand, is great for one server at the branch and then another server at the home office that you can have be your hot standby. That's the most common use that I expect to see this for. We're going to give 95% of the scope to the local server, but if he goes down for any reason, we'll start failing that over, and now the home office can actually take over and issue that. If we're talking about your average, situation here, like a reboot, then he will just hold on to that 5%, hand out any new leases that he needs to hand out, and then when the guy comes back after a reboot, he takes back over. Stale switchover interval defines, and it's by default 60 minutes, defines how long are we going to wait before the backup server assumes that primary server is never coming back and will take over as the primary. So then we complete the wizard by saying next and finish. We'll see it go through successful, configure successful, etc., etc. Alright, so now when I go over to the other server, we will have a scope over here that's identical to the scope over there. Now, if I look at the policies, we'll see the test policy did make it over as well. Now, the thing about these replication is that not everything is always going to replicate. You may, on a few occasions, have to right-click and replicate the failover scopes. Right-click on the scope, or replicate the entire scope to the other guy, because some changes that you make may not make it over there. Let's just say that I create a new reservation. So we'll call this my res, and we might give that to let's see, 55, and we might call it, and add that in. Oh, close. I've got a reservation. Go over to reservations over here. He doesn't see this, so refresh it. Oh, it's still not there. Why? Because we haven't replicated the scope. I'll show you another thing that does not typically replicate over. IETF draft does not specify this, therefore it's not in here. So sticking with open standards, we are limited what the standard says, so it's just not there. So let me just create another really quick policy here. Pause the video. So now we've got two policies. I just created the other one. Pause the video just so you wouldn't have to sit and watch me do something I've already done. Maybe give you an idea of what I meant by moving up and down. So we've got this in the processing order. Go down to policies down here, refresh. Okay, nothing's there. Why is that? Well, because replication doesn't automatically happen for everything. Now, the scope itself is going to be replicating between the two servers. Any leases that have occurred will all be replicating back and forth, but there are certain parts that do not replicate. You have to say replicate the scope. This is push-based replication. Make sure you do the replication from the DHCP server in which you made the change. A lot of Microsoft technologies are pull-based replication, so don't get these confused or you might make a mistake and overwrite your changes. Replicate the scope, he pushes that over there. Now I should be able to come in here and see that policy after a refresh. We will also see reservations, probably after a refresh. And there's my reservations. So that's kind of the big catch here. When we start talking about this high availability, just one catch is that for now, replicating the scope is going to be something that you'll want to do to manage on outside of that process, because it's not going to automatically happen for you. But anyway, this has been episode 7 of the What's New in Windows Server 2012. So anyway, guys, this has been Chris with Microsoft. As always, thank you for watching. If you did find anything about this useful or interesting, please take the time and give it a quick like. Feel free also to subscribe to my channel. My blog is also at 9z.com, just the number 9, the letter z.com, real easy to remember. That's also got links to my Facebook, my LinkedIn, and Twitter. So again, thanks a ton for listening, and I'll see you all in the next episode.